Good day, everyone. So, our topic for today is about illustrating experimental and theoretical probability. So, I am Maria Paulette M. Salsada together with Mr. Leonardo A. Tidalgo. Our lesson objective is to identify and differentiate the experimental and theoretical probability and able to formulate and solve practical problems involving experimental and theoretical probability. Before we proceed to our lesson proper, I have here an activity to answer. Direction: complete the table below. So I have here two tables, which is the first table shows the outcomes and the frequency, which is you have to identify the frequency of getting ahead and a tail and its total. The second table shows the outcome of every trail. So I will be giving you 3 minutes to answer this activity. Since the 3 minutes is done, I'll be revealing the answers. For our head, the frequency is 5, also for our tail, a total of 10. So if you got it right, please comment down below your scores. Now we are going to proceed to our lesson proper. So take note that probability may be categorized as theoretical probability or experimental probability. Let us differentiate each other. Now, when we say theoretical probability, it is what you expect to happen but isn't always what actually happens. Meaning, it is expected already. It is based on possible outcomes and we are assuming that events are equal. Take note that it is also called theoretical because it is determined based on reasoning. So we use the formula of P sub E is equal to the number of favorable outcomes over total numbers of possible outcomes. So we will understand it more if we have example. Under theoretical probability, for example, you are to toss a coin. So using the formula P sub E is equal to the number of favorable outcomes over the total number of possible outcomes. I have here provided a sample picture. And from there, we know that our sample space when we toss the coin is a head and a tail. And for getting the probability of getting ahead, how many head do you see from our example? Yes, we have one. We have only one and our possible outcomes is 2. Therefore, the probability of getting ahead is 1/2. How about the tail? How many tail do you see from our example? Yes, we have only one and our possible outcome is also 2. Therefore, the probability of getting a tail is 1/2. I have here another example. A bag contains 3 red marbles and 3 blue marbles. Again, we use the formula P sub E is equal to the number of favorable outcomes over the total numbers of possible outcomes. So the probability of getting 3 red marbles from the bag is 3 and our possible outcomes is 6. Why 6? Since the bag contains 3 red marbles and 3 blue marbles, which is equal to 6. So therefore, the probability of getting the red marbles is equal to 3 over 6 or equal to 1/2. So the result is based on the possible outcomes.
Hello everyone, I am Leonardo A. Tidalgo and I am your teacher on this lesson. I will be discuss about the experimental probability. What do you think is the experimental probability? When we say experimental probability, it is what actually happens instead of what you're expecting to happen. It is found by repeating an experiment and observing the outcomes. And it can be calculated based on the number of possible outcomes by the total number of trials. Here is the formula for the experimental probability. We have P of E is equal to the numbers of times event occurs over the total numbers of trials. I will give you the example to deep understanding on this lesson. We have the example for the number 1. A coin is tossed 10 times, a head is tossed is recorded 7 times, and a tail 3 times. As you can see in the formula, we have the numbers of time event occurs over the total number of trials. What do you think is the numbers of time event occurs for the head? Yes, that's right. It is 7 times. How about for the tail? Yes, that's right. It is 3 times. Then, how about the total number of trials? Yes, that's right. It is 10 times. So, we have for the head, we have 7 over 10. And for the tail, we have 3 over 10. Another example. You draw a marble out of the bag and you record the color and replace the marble. After 6 draws, you record 2 red marbles. As you can see in the table, we have 6 trials and we have the red and blue marbles. We are looking for the red marbles. What do you think is the number of times event occurs for the red marbles? Yes, that's right, it is 2. How about the total numbers of trials? It is 6. For the red marbles, we have 2 over 6 or 1 over 3. Then the result is found by the repeating an experiment. So that is for the experimental probability.